Okay, so today we're going to talk about sets and subsets, and this is our unit 1, and that's how can we represent numbers. Okay, so when I'm looking at this, a set is a collection of objects such as numbers in which order does not matter, and a subset is made up of objects from another set called a parent set. So we're going to talk about that together. So you have the choice to either print this handout out off or kind of write these examples out on a lined piece of paper. So what I want you to start by doing is I want you to list all of the numbers from 1 to 10. So pause the video while you do that. Okay, so if you've listed all the numbers from 1 to 10, you've probably got a list that looks something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are called elements of a set. And when we talk about sets, we have a special set of notation. And the notation that we work with when we talk about sets is this. This is like a curly bracket at the ends of the set saying that those are the numbers that belong to the set, and all the numbers listed inside are the elements of the set. And we usually use a letter to show that we're talking about a set. So I'm going to call this set set A. So I've got set A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So from this set, I want you to create a subset. So that means it has to be the numbers that I've already written down. So a subset of A, and we're going to do only the even numbers. So I want you to pause the video and I want you to write down that list. Press play when you're ready. Okay, so if I look at the subset that has only even numbers, I've got, okay, so my 2, my 4, my 6, my 8, and my 10, because those are the even numbers. So I'm going to take, and I'm going to use B as my subset, so B is equal to, and I use that curly bracket again because I'm still talking about a set, so a set from within a set, and I'm going to list those numbers, 2, 4, 6, 8, and 10. Okay. The next subset I'm going to ask you to do is the subset of the multiples of 5. So look at your list and create a subset of the multiples of 5. Pause the video and press play when you're ready. Okay, so when I look at this, I'm going to call this set C. And from my original set, so if I look here, I've got 5 as a multiple of 5 and 10 as a multiple of 5. So I'm going to write those down. I've got 5 and 10. So these are considered subsets because the numbers that are in set A exist in both B and C. Okay, and then can you create its own separate set, and I'll call it set F, of the numbers that are in both of the subsets that you've created. So take a second and do that. Pause the video. So when I look at this list, 10 is the only number in both sets. So I'm going to say, okay, my new subset of both of those subsets is 10. Okay, we are going to do some more practice writing sets. So I've got a couple examples here. Each time I want you to pause the video, try the example, and then press play to make sure that you're correct. So write the set of integers greater than negative 10. So pause the video, press play when you're ready. So I'm going to call this A again. So the set of integers greater than negative 10. So if I look at this, I've got negative 10, negative 9, negative 8, negative 7. The thing is that this set could go on forever and ever and ever. And I don't want to have to write those all out. So when I get stuck about writing them on forever and I'm following a pattern, I'm going to use ... to show that that pattern continues in the same way. So that's set A. All right, now I want you to try, we're going to call this one set B. So take a second and write the set of positive whole numbers that are multiples of 2 less than 20. Okay, so here we go. Multiples of 2 less than 20. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18. And sorry, we're not going to include 20. The reason why we're not going to include 20 is that it says less than. It does not say equal to. So 20 is not included in that set. All right. Write set C, and set C is the set of all integers. So take a second, pause the video, and try this one. Okay, so again, the set of all integers is a really, really big one. So I might go, okay, I want to be able to see the pattern. So I've got -3, -2, -1, 0, 1, 2, 3. But obviously it goes infinitely in both directions. So I'm going to go dot, 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 showing that it goes infinitely in the positive direction. And I'm also going to go dot, dot, dot in the negative direction to show that it goes infinitely in both ways. Oh, and I've got the same thing written twice, so we're just going to cross this one off. All right, so here we go. Just 2 questions about subsets, and then we are done this quick video. So explain why set 7, 9, and 12 is a subset of set 5, 6, 7, 8, 9, 10, 11, 12. So pause the video and take a second to explain that. So remember we talked about if something was going to be a subset, that means that all of these numbers here, 7, 9, and 12, have to exist in the other set. So if I look here, I've got 7, okay, that exists in that set, in both sets. 9, that exists in that set, and 12. So I can say, so if this was subset A and this is subset B, I could say that all of set A is in set B. Therefore, set BA is a subset of B. Okay? And then the next one says, explain why the set 0, 1, 4, 9, 16, so those are called square numbers, is not a subset of set 1, 2, 3, 4, 5, dot, dot, dot. So take a second and explain that. Pause the video. So when I look at this set, all of these numbers, 1, 4, 9, 16, would exist because I've got 1, 4, 9, and 16 would continue in these dot, dot, dots. The problem in this set is 0, because 0 is not in both sets. So therefore, it is not a subset. All right, so there you are. There is your quick note on sets and subsets. Make sure you've taken an opportunity to write that down.